All right, so for the last page, we have 3 segments, or lengths, or segments, and we're trying to create a triangle, and then we're trying to make the triangles different. So I would recommend, because of the space that we have available, that we make the bottom segment length 7. That way, we can hopefully make sure the triangle will actually fit the paper. The idea again is, can I get 2 different triangles, different as in shape, size, in such a way that our transformations will not make the triangle fit perfectly. So can you come up with a way to do that? So beginning with 7 at the bottom is my recommendation. Try that. For problem 11, we are given 2 lengths. So beginning with, I would suggest maybe making it a length of 4 and a length of 5. Since we have 2 different lengths, kind of like we did on the previous page. And let's see if, and again, it's impossible to come up with 2 different triangles. And the idea here is to come up with all the possible triangles in problem 11 and all the possible triangles in problem 9. So if you need to, come out here to the left to kind of map it out. If you need to, but put 7 at the bottom. And how many different ways to kind of come up with a triangle and place these lengths. Same thing at the 5 at the bottom or the 4 on the bottom. How many different triangles can we come up with that we believe are going to be different? So maybe mapping it out will also be helpful. So if you go ahead and get started on problem 9, when you get that finished, and you have had a discussion with the partner, turn the video back on, and we'll take a look at the solution for problem 9. So if I put the 7 in the bottom, then that means the 4 and the 5 have to come off of each end point. And if I keep the 7 on the bottom, the only other choice I have is just simply to switch the 2 numbers, which basically is like taking this triangle and flipping it over like a line of reflection, which will put the 5 on the left and the 4 on the right. So it appears that there is only going to be 1 triangle. So I'm going to go ahead and draw a length of 4 and a length of 5. So I already have those preset. Sometimes when you're doing constructions, actually drawing the segments up front that you need sometimes can save you some time. So I'm going to put a 4 on the left. And this is for demonstration. I'll put a 4 on the right, since there's only 2 places I can put the 5 and the 4. And then I'm going to put a 5 on the right, the first one, and a 5 on the left, the second one. And that's going to give me, let's see. So if I connect those, I like putting the endpoints in because it's a good way to make sure that when I'm connecting the points that I'm actually going to the endpoint of the segment and not somewhere else because of the circles that I'm drawing. So this is the 4 centimeter side, this is the 5, and over here it's switched. And the question is, do I get the same triangle? Hopefully you can kind of look at it and get that idea, but just for verification. We do get the same triangle, and there isn't there isn't any other combination other than what we've done here. If I put the 7 at the bottom, this is it. So is there another possibility? The answer is no. There's only 1 triangle. So I'm hoping that, again, that you and your partner only came up with the 1 triangle. It was the same triangle. Hopefully you could verify it quickly that Your triangles would be the same as a piece of patty paper. So again, as I talked about in the last video, if I would say to everybody in class, please construct a triangle with lengths 3, 5, and 7, hopefully going into that problem, we understand that all of us are going to get the same triangle. It may be flipped over, it may be rotated, but the triangle itself is going to be the same because there's only essentially one way of putting the triangle together. All the other combinations are just simply some type of rigid transformation. Alright, so for this problem here, I'm going to focus on, I suggest focusing on the 5 first, and then trying to see, again, if there's other combinations. So, for example, if I put a 5 at the top, that means off the left side, I can put the 4, and off the right side, I can put the 30. That would be one combination. If I would switch the 30 and the 4, that would be like taking the triangle and flipping it over. So I like up here, I hope we understand that we're just getting the same triangle back. So is it possible to keep the 5 on the bottom and using the 2 numbers here and get triangles that we believe would be different? And if so, we'll take a look at those. So go ahead and think about that. Have a conversation with your partner. Is there any way of arranging the 4 and the 30 so that it would be different than what we're showing here, so that it wouldn't be a transformation of some sort to get from one to the other? Turn the video back on when you think you have all the combinations. Again, if you think there's another possibility, then with the 5 on the bottom, then put that combination together as well. So think about it. We'll talk about it. It's kind of like a think, pair, share. So think about it. Write down your ideas. Share your ideas, and then come back and we'll take a look at the problem. All right. So if I keep the 4 on the left, the 30 actually has 3 places that can go. It can go here between the 4 and the 5, and that would definitely be different than this. Because right here, the 4 is actually opposite the 30. Here, the 30 is not opposite the 4. And another possibility, I keep the 4 here, and what I could do is I could put the 30 at the top to make the 30 opposite the 5. So in terms of just moving the 30 and leaving the 4 and 5 where it's at, we can place the 30 in 3 different places. So hopefully, again, these 3 combinations might be 3 different triangles. And then the question here is, okay, so if I put the 4 at the bottom and I place the 5 and the 30, is it possible to come up with another combination that's not already on the paper? So think about that if you haven't, and turn the video back on when you are ready. So if I put the 5 on the right side, for example, or sorry, left side, then 30 again has 3 places. I can put the 30 here, which means it's opposite the 5, and that would be the one down here. I could put the 30 here, and that would be this combination just flipped over. Or I could put the 30 up here at the top, which means the 30 is opposite the 4, which is the first example. So in terms of combinations, there are no other combinations. So the question is, are these 3 combinations going to give me the same triangle, or are they going to give me different triangles? So, so the 5 on the bottom, we can put 30 off the right side and a length of 4 off the left side. I would recommend putting the points here, because that way we know when we're drawing back to those endpoints. So go ahead and construct that triangle if you haven't. Turn the video back on when you're finished. Go ahead and think about the next triangle. Put the 5 on the bottom, so I draw another 5. Is it possible to put the 30 on the left and the 4 on the left? And the last one, how would you construct the last one? So, when you're finished, again, turn the video back on. Alright, so for the first one, put the 30 on the left, Comes our right, 30 on the right side. And then on the left side, I want a 4. So I'm going to make a length of 4, then I'm going to construct a circle. And when I construct the circle, you'll notice that the circle extend the side is going to touch up here. So that's point C. Or actually, like a different color, let's make that B. And if I connect that back to C, that's going to be one triangle. So I have 30 on the right side and the 4 centimeters on the left. So that's one triangle combination. This one here, I'm going to put the 30 and the 4 on the left. So 30-degree angle on the left side. So there's my 30. And then using the 4, I'm going to draw a length of 4. I want to get the circle and the angle, the leg of the angle to match up. That would be here. Let's call that point G. So I'm going to draw an F back, or G and F to make the third side of the triangle. So this is 5, this is 30, and then the left side here is the 4, going out to G. So those two triangles definitely look different. And then the last one, we have the 5 and the 5 and the 30 are opposite each other. So this one actually can be done better if I put the 4 on the bottom. And if the 4 is on the bottom, I can put the 5 on the right side, and I can put the 30 on the left side. So if you haven't constructed these, all you've been doing is following along with me. Would you please construct the last triangle, and then turn the video on when you've constructed it. Alright, so as I said, I'm going to put the 30 on the left and the 5 on the right. So 30-degree angle on the left. And then the right side, we're going to construct a circle with a length of 5. That's the radius. And we're going to intersect the angle, which is going to be up here. So I'll call this point C up here. And connect B back to C. So 30 on the left, 5 on the right, 4 on the bottom. So all together we have here 3 triangles. So the answer is it possible to make no triangles? The answer is yes. There are other triangles. I'm going to pose the question here based on the construction that I just did. Is it possible to get a 4th triangle? So I want you to look at this one I'll leave off. I want you to look at the constructions, and based on the construction, do you see another way of getting another triangle using one of the 3 patterns? So it's your 4th triangle. So see if you come up with a 4th triangle using the same information based on what I did. So from here, you're going on to Delta Math assignment due on Sunday, and you also have some workbook problems to do. Workbook problems are going to be discussed on Friday during class, at the end of class, so if you don't get them done, hopefully you'll have some time Friday to finish them up. With only 4 workbook problems, so hopefully you have plenty of time to get those done in class today, plus also work on Delta Math if you're not finished with that. Come back with any questions you might have on this activity on Friday.